Somewhere out beyond the orbit of Neptune, further from the sun than any human being has ever traveled, a small metal spacecraft the size of a compact car turned itself around. It had been flying in one direction for nearly 13 years. Its cameras pointed forward, its mission focused entirely on the giant planets ahead of it. But on a single day in February of 1990, mission controllers on Earth sent it a set of commands that told it to do something it had never been asked to do before. Look back, point its camera not at what lay ahead, but at everything it had already left behind. What that spacecraft captured in the next 34 minutes would become one of the most studied, most quoted, and most emotionally devastating images ever produced by human technology. And then, almost immediately after taking it, the spacecraft's eyes closed forever. It has not taken a single photograph since. Not one. For over 3.5 decades, one of humanity's furthest flung machines has continued flying deeper into the darkness of interstellar space, completely blind. Its cameras permanently switched off, carrying inside its memory the very last thing it ever saw. That spacecraft is Voyager 1, and the story of its final images is not simply a story about a photograph. It's a story about a decision that still divides scientists and engineers to this day, a decision made under pressure against internal resistance for reasons that had almost nothing to do with science and almost everything to do with meaning. It's a story about how an aging piece of 1970s technology, held together by systems considered obsolete before most people alive today were even born, was pointed directly at the blinding light of the sun in a maneuver so risky it could have destroyed the very cameras it was trying to use. And it's a story about what happened when humanity, for the first time in its entire existence, got to see itself the way the rest of the universe sees it. Not as a bustling world full of cities and oceans and mountain ranges, not even as a blue marble hanging in space, the way astronauts had photographed it decades earlier from the orbit of the moon, but as something almost impossible to comprehend. A single point of light, smaller than a pixel, adrift in an ocean of nothing. To understand why this moment carried so much weight, you have to go back to where Voyager 1's journey actually began, and just how extraordinary that journey already was by the time this final photograph was ever considered. Voyager 1 launched from Earth in September of 1977, riding into space atop a Titan Centaur rocket, carrying instruments built with the kind of engineering common to the disco era: analog systems, magnetic tape recorders, computers with a tiny fraction of the processing power contained in a modern digital watch. It wasn't even the first of the twin Voyager spacecraft to leave Earth. Its sibling, Voyager 2, had launched a few weeks earlier. But Voyager 1 was placed on a faster trajectory, and within months it overtook its twin, eventually earning the number 1 in its name specifically because of the order in which the two probes were destined to reach their first target: the massive, swirling clouds of Jupiter. What followed was one of the most audacious and successful scientific missions ever attempted. Voyager 1 swept past Jupiter in 1979, capturing images that stunned scientists, including the first close-up evidence of active volcanoes on Jupiter's moon Io, a discovery nobody had expected, and one that fundamentally reshaped how scientists understood the moons of the outer solar system. From there, Voyager 1 continued on to Saturn, arriving in November of 1980, where it captured detailed images of the planet's rings and its massive moon Titan, hidden beneath a thick, mysterious atmosphere that scientists were desperate to study. And then, after Saturn, mission planners made a defining choice for Voyager 1's future. Rather than continuing on toward Uranus and Neptune the way its twin Voyager 2 eventually would, Voyager 1 was deliberately steered onto a trajectory that would take it close to Titan for a detailed scientific study, a maneuver that came at a permanent cost. The gravitational path required to get that close to Titan flung Voyager 1 up and out of the flat orbital plane in which all the planets circle the sun, sending it on a course that would carry it away from the solar system entirely, never to encounter another planet again. From that point forward, Voyager 1 was no longer a planetary explorer in any traditional sense. It became something else entirely. A lonely traveler heading outward into the vast emptiness between the stars, its instruments still running, its radio still faithfully transmitting data back toward a planet growing smaller and smaller behind it with every passing day. It's worth pausing on just how deliberate and consequential the trade-off actually was, because it wasn't an accident of orbital mechanics. Mission planners weighed the decision carefully, understanding fully that steering Voyager 1 close enough to Titan to study its thick, hazy atmosphere in detail would permanently end any possibility of the spacecraft ever visiting Uranus or Neptune the way its twin eventually would. They chose Titan anyway, judging the scientific value of studying that strange, cloud-covered moon to outweigh the loss of 2 additional planetary flybys. It was a bet made in 1980, a full decade before anyone seriously discussed turning Voyager 1's cameras back toward Earth. And it quietly set the entire stage for everything that followed, because it guaranteed that by the time the family portrait idea was finally proposed, Voyager 1 would already be far enough beyond the solar system's planets to capture all of them, including Earth, in a single sweeping sequence of exposures. For nearly a decade after leaving Saturn, Voyager 1's cameras sat essentially idle. There was nothing left to photograph. No more planets, no more moons, nothing but the increasingly sparse scattering of background stars, far too distant and far too dim for Voyager's aging optical systems to capture anything scientifically meaningful. The imaging team that had once processed thousands of dazzling photographs from Jupiter and Saturn had largely moved on. The cameras themselves sat powered down for years at a stretch, an expensive, power-hungry system with seemingly no remaining purpose on a spacecraft that needed to conserve every watt of electricity it could for its long journey ahead, a journey expected to stretch on for decades, potentially even into the next century. It was against this backdrop of practical, unsentimental mission planning that one scientist began pushing for something almost nobody else on the mission wanted to do. Carl Sagan, the astronomer, author, and one of the most recognizable scientific voices of his generation, had been part of the Voyager imaging team since the mission's earliest planning stages. And for years, Sagan had been quietly advocating for an idea that most of his colleagues considered, at best, a distraction, and at worst, a genuinely risky and pointless use of a fragile, aging spacecraft's remaining capabilities. Sagan wanted Voyager 1 to turn its camera around, not toward another planet, not toward any object of clear scientific value, but back toward Earth itself, transforming the most distant functioning camera humanity had ever built into a mirror aimed at ourselves. The scientific value of such an image, by any conventional measure, was essentially non-existent. Earth, from Voyager 1's position billions of miles away, would appear as nothing more than a single point of light, far too small and far too dim to reveal any meaningful surface detail, weather patterns, or anything resembling the kind of data planetary scientists typically extract from spacecraft imagery. Many of Sagan's colleagues on the mission argued exactly this point, questioning why they should spend valuable spacecraft power, valuable data transmission bandwidth, and valuable operational risk on an image that would tell scientists essentially nothing new about Earth that they didn't already know. But Sagan wasn't interested in scientific data. He was interested in perspective. He believed, and would later write extensively about, the idea that seeing Earth from such an almost incomprehensible distance, reduced to nothing more than a single fragile speck of light suspended in the vast darkness of space, might fundamentally change how people understood their place in the universe. It wasn't an argument rooted in astronomy. It was an argument rooted in psychology, in philosophy, in the stubborn belief that some images have power that has nothing to do with the information they contain and everything to do with what they force the viewer to confront. For years, Sagan's proposal went nowhere. Mission engineers had legitimate, serious concerns about the maneuver required to actually capture the image. Turning Voyager 1's cameras back toward the inner solar system meant pointing those delicate optical instruments dangerously close to the sun, a maneuver that carried real risk of permanently damaging the camera's sensitive imaging system, if the alignment was even slightly miscalculated, essentially threatening to burn out the very equipment being used to capture the shot. There was also the question of timing. Voyager 1's imaging system, powered by a computer that controlled camera operations, was scheduled to eventually be permanently deactivated entirely, its remaining capabilities repurposed to help manage the spacecraft's other critical, long-term systems, as it settled into decades of interstellar cruising with drastically limited power reserves. Once that shutdown happened, there would be no reversing it. No second chance, no opportunity to ever attempt this photograph again. By late 1989, with the shutdown deadline finally approaching, Sagan's persistence, combined with support from key figures within the mission's leadership, finally won out. NASA and the Jet Propulsion Laboratory approved the plan. Voyager 1 would attempt what came to be informally nicknamed, both at the time and in retrospect, the family portrait, a coordinated sequence of images capturing several planets of the solar system from Voyager's unique vantage point beyond Neptune, culminating in an attempt to photograph Earth itself, a planet so distant and so small from that position that engineers weren't even entirely certain the resulting image would successfully capture it at all. Preparation for the sequence took months. Engineers had to carefully calculate the precise timing and camera angles required, accounting for the spacecraft's position, its distance from each target, and the extreme technical challenge of pointing an aging camera system with pinpoint precision at objects so far away and so faint that any error in the calculations could result in images showing nothing but empty space. On February 13th and 14th of 1990, the commands were finally executed. Over the course of those 2 days, Voyager 1 captured a sequence of 60 images, methodically photographing the Sun along with 6 of the solar system's planets, each one reduced by the spacecraft's staggering distance to nothing more than a tiny, faint point of light scattered against the surrounding darkness. The final images in that sequence, captured at 4:48 in the morning, Greenwich time, on February 14th, 1990, were of Earth. 3 separate exposures, using different color filters, were combined afterward to produce a single composite photograph. one that would eventually become known around the world by the name Sagan himself would later give it in his writing, the pale blue dot. What makes the actual content of that photograph so strange and so quietly devastating is just how little there technically is to see in it. Earth, from Voyager 1's position roughly 3.7 billion miles from the Sun, occupies less than a single pixel within the frame. It isn't even immediately visible to an untrained eye scanning the image. Scientists processing the data had to specifically identify and enhance the tiny cluster of pixels representing our entire planet just to make it visible at all. And by pure, almost poetic coincidence, Earth's position within the frame happened to fall directly within a scattered band of sunlight, an unintended streak of lens flare caused by scattered light bouncing through Voyager's aging camera optics as they pointed dangerously close to the sun's blinding glare. The result is an image where Earth appears as a single, barely perceptible speck of pale blue light, seemingly suspended within a diagonal beam of scattered sunlight cutting across an otherwise empty black frame. It is, by nearly every conventional standard of photography, an unremarkable image. Grainy, poorly lit, technically compromised by an optical flaw nobody intended, and yet it went on to become one of the most powerful, most widely reproduced, and most emotionally resonant photographs ever taken by any camera, human-operated or otherwise, in the entire history of space exploration. The reason for that power lies almost entirely in what Sagan did with the image afterward, in the words he wrote to accompany it, words that transformed a nearly invisible smudge of light into one of the most quoted meditations on human existence ever written. In the years following the photograph's release, Sagan published a book built entirely around this single image, using it as the foundation for a broader reflection on humanity's place within the staggering scale of the universe. He wrote about how every human being who had ever lived, every war ever fought, every king and empire, every act of triumph and every act of cruelty in the entirety of recorded human history had all played out entirely upon that single, barely visible pixel of light. Every person you have ever loved, every person you have ever known, every human being who has ever existed, lived their entire life on that one pale blue dot, suspended in a beam of scattered sunlight and nowhere else. It's worth sitting with the actual physical reality of how that image was made, because the process behind it is almost as strange as the photograph itself. Voyager 1, by February 1990, was already using instruments and imaging technology that had been considered aging even at the time of its 1977 launch. Its cameras relied on television tube-based imaging systems, a completely different, far more primitive technology than the digital sensors used in virtually every camera built today. Data captured by those cameras wasn't instantly transmitted. It was first stored on an onboard tape recorder, then gradually beamed back toward Earth using Voyager's radio transmitter, a signal so faint by the time it crossed billions of miles of empty space that it required NASA's massive deep space network of radio antennas positioned strategically around the globe, working continuously just to detect and capture it. The full data set from the 60-image family portrait sequence took multiple separate communication passes, spread out over more than 2 months before the complete set of images had finally fully arrived back on Earth, with the last of the data not reaching mission scientists until the 1st of May, 1990. And then, just 34 minutes after capturing that final image of Earth, mission controllers executed the plan they had been building toward for years. Voyager 1's cameras were permanently powered down, not paused, not placed into a low-energy standby mode awaiting future reactivation. Permanently shut off, their imaging system's dedicated computer repurposed to help manage other critical spacecraft functions as Voyager 1 settled into the long, dark decades of its interstellar journey ahead, a journey where every available watt of remaining power needed to be preserved for the instruments still capable of returning meaningful scientific data, rather than a camera with nothing left to photograph. To this day, Voyager 1 has never taken another picture. It cannot. Adding to the irreversibility of that decision, engineers made another critical move several years later in 1996, deliberately switching off the heating systems that had kept the camera's internal components from freezing in the brutal cold of deep space, a move made purely to conserve the spacecraft's dwindling power supply for its higher priority scientific instruments. Once those heaters were shut down, the extreme cold of interstellar space almost certainly caused irreversible physical damage to the camera systems, meaning that even if some future engineer wanted to attempt reactivating Voyager 1's imaging capability, the hardware itself likely wouldn't survive the attempt. The pale blue dot and the handful of family portrait images captured alongside it aren't simply Voyager 1's final photographs by choice. They are its final photographs by physical necessity, permanently, irreversibly, for the remainder of the spacecraft's operational life. And that operational life, remarkably, is still ongoing. More than 3.5 decades after its cameras went dark forever, Voyager 1 continues flying outward into interstellar space, continues receiving and executing commands sent from Earth, and continues transmitting scientific data back across a communication distance so vast that a single radio signal traveling at the literal speed of light takes over 22 hours to complete the one-way journey between the spacecraft and mission control. Voyager 1 currently holds the singular distinction of being the single most distant human-made object in the entire known universe, having crossed the boundary of our solar system's heliosphere back in 2012, officially entering true interstellar space, a boundary its twin, Voyager 2, wouldn't cross until 2018. The spacecraft's continued survival, decade after decade, running on a rapidly diminishing supply of power generated by the slow radioactive decay of plutonium inside its onboard generators, has forced NASA engineers into an ongoing, almost surreal process of managing its remaining capabilities, systematically shutting down individual instruments and systems one by one over the years, prioritizing which scientific functions matter most as the spacecraft's available power continues shrinking towards zero. The imaging system was simply the earliest, and, in hindsight, one of the most emotionally significant systems to be sacrificed in that long, ongoing process of managed decline. Engineers have described the last several years of Voyager 1's operational life as an exercise in triage, turning off one heater here, one backup system there, carefully monitoring exactly how many watts each remaining instrument draws, aware that every shutdown is permanent and every remaining system is now living on borrowed time. At various points, ground controllers have had to work around corrupted onboard computer memory by rerouting commands through decades-old backup systems that were never originally designed to carry that particular load, essentially performing long-distance surgery on a patient more than 22 light hours away, using documentation written by engineers who have since retired or passed away. Every successful fix is treated as something close to a small miracle, proof that a machine built with 1970s technology can still be coaxed into functioning correctly across a delay so long that a single question and its answering command take nearly 2 full days to complete a round trip. Eventually, expected sometime within the next decade, Voyager 1's plutonium power source will decay to the point where it simply cannot generate enough electricity to keep any instrument or even its radio transmitter running at all. When that day comes, the spacecraft will not explode or break apart or announce its ending dramatically. It will simply go quiet, its last transmission arriving as a faint signal indistinguishable from the routine data it has sent for nearly 50 years, before falling permanently silent and drifting on forever, carrying its frozen camera and its last photograph deeper into interstellar space, long after everyone who built it launched it, and photographing that pale blue dot has passed away. What makes the story of Voyager 1's final images so genuinely startling when you step back and look at the full picture isn't simply the photograph itself, faint and technically flawed as it is. It's the layered improbability of everything that had to align for that image to exist at all. A scientist had to fight for years against practical, reasonable objections from his own colleagues, simply to be allowed to point an aging camera at an object with essentially zero scientific value. Engineers had to execute an extraordinarily precise and genuinely risky maneuver, threading a camera's field of view close enough to the blinding sun to catch Earth in frame without destroying the very instrument capturing the shot. That instrument, built with technology already considered outdated by the standards of its own era, had to function flawlessly one final time, more than 12 years after launch, having already survived the radiation belts of Jupiter, the ring systems of Saturn, and over a decade of continuous exposure to the punishing environment of deep space. And the resulting data had to successfully cross billions of miles of empty space, arriving back on Earth intact before the very system that had captured it was permanently switched off forever, closing its eyes for the final time, only minutes after opening them just long enough to look back at everything it had ever known. It also helps to place the pale blue dot alongside the handful of other self-portraits humanity has taken from space, because the comparison reveals just how radical Voyager 1's final image really was. In 1968, astronauts aboard Apollo 8 captured the famous Earthrise photograph, showing Earth as a vivid blue and white sphere rising over the gray, cratered horizon of the Moon, 250,000 miles away. It remains one of the most iconic photographs ever taken, but Earth in that image is unmistakably a world full of visible detail, clearly alive, clearly ours. The pale blue dot offered something almost opposite. Taken from roughly 15,000 times farther away than the Apollo 8 astronauts ever traveled, it stripped away every trace of detail, every continent, every ocean, every cloud, leaving nothing but a single point of color barely distinguishable from noise in the camera's sensor. Where Earthrise inspired awe at the beauty of a living planet, the pale blue dot inspired something closer to vertigo, a quiet, unsettling confrontation with just how small and how fragile that same living planet actually is when viewed from far enough away, out in the cold and the dark. Sagan never lived to see the image's influence continue to grow decades after its capture. He died in 1996, only 6 years after the photograph was taken, but the words he wrote about it have long outlived him, repeated in classrooms, planetariums, documentaries, and commencement speeches around the world, still cited today as one of the clearest, most accessible explanations ever offered for why humanity might want to look up and outward rather than only down at the ground beneath its own feet. Every few years, on the anniversary of that final photograph, NASA engineers and scientists revisit the original data using modern image processing techniques far more advanced than anything available in 1990, producing sharper, cleaner versions of the same grainy original frame, careful each time to preserve the essential character of the picture Voyager 1 actually captured. Rather than manufacturing a false sense of clarity, the spacecraft's aging cameras were never capable of providing in the first place. Today, that photograph exists as something closer to a kind of cosmic time capsule than a conventional piece of scientific data. It is, quite literally, the last thing an entire category of human technology ever saw before going permanently blind. And what it chose to look at, in its final moments of sight, was home. Every time someone looks at that faint, grainy image today, that single pale point of light caught inside a scattered beam of accidental sunlight, they are looking at the very last photograph a spacecraft took before the lights went out forever. A spacecraft that is, even now, continuing to fly further and further away, deeper into a darkness so complete and so vast that the light from our sun will eventually fade entirely from its instruments, leaving Voyager 1 to drift on, silent, blind, and alone, carrying within its permanently frozen memory banks the very last image it will ever hold. A tiny, fragile dot of pale blue light, suspended for a fraction of a second, in a beam of sunlight 3.7 billion miles from home.